talking about how to find roots of a polynomial. Let's do a quick warm-up example of how to find those. So we know if we're given a polynomial like this, that the degree will tell us how many roots this polynomial has, which is 3. Now, to get a list of possible rational roots, we're going to look at factors of the constant term divided by the factors of the leading coefficient. That is our rational roots theorem. Now, factors of -1 are plus or minus 1, and factors of our leading coefficient are also plus or minus 1. So when we look at those together, it really only gives us 2 options. So my possible rational roots are only plus or minus 1. Now already that might make you think, well, we are going to have 3 roots. How does that work if we only have 2 options? Well, maybe there's multiplicity, maybe it's something else. Let's figure it out together. So how I check if it's actually a root is I'm going to plug it in. That's the remainder theorem, and hope that we get 1. Hope that we get 0. We're plugging in 1, hoping we get 0. So I'm going to plug in 1. 1 cubed is 1. 1 squared is 1. And sure enough, I get 0. What that tells me is that 1 is a root. And since it's a real number, it's going to be an x-intercept. That also means the quantity of x minus 1 is a factor of f of x. Now there's 2 more roots, so what we're going to do is we're going to take f of x and we're going to divide it by x minus 1. And the easiest way to do polynomial division, in my opinion, is synthetic division. So we're going to use our root 1, and we're going to divide f of x by quantity x minus 1. So we're going to write the coefficient 1, negative 1, 1, negative 1. Follow the steps of synthetic division. And sure enough, we get 0. We knew we'd get 0 from the remainder theorem, but we're more interested in the quotient here. So what we get is that this 0 is our remainder, constant, linear, and quadratic. So after we have divided it, we get x squared plus 1. So we divided out x minus 1, and this is our quotient. Now there's 2 roots remaining in there. We need to find out what those are. To find that, let's set it equal to 0 and solve. I'm going to subtract 1, and I get x squared is negative 1. And to get rid of the squared, we square root, and we've got the square root of negative 1. Do you remember what that is? This is going to be plus or minus I. I is our imaginary number because you can't take the square root of a negative. So this is, I is the square root of negative 1. That's the definition. We have plus or minus I. So when you do a square root, you have to do both. So this example here is showing us, yeah, we have 3 roots, but only one of them was real. We had 1, I, and negative I. So up to this point, when we've been solving these, we've always gotten real, rational roots. But it is possible to get irrational roots, or as we saw in this example, imaginary roots. When we graph this, these won't show up as x-intercepts. The only x-intercept will be 1. We're going to do more examples working with these imaginary or complex numbers. All right, so here's the objectives for today. You're going to be able to find complex roots of any polynomials using the conjugate's roots theorem, and then we're going to write polynomials with complex roots in standard form. So let's do another example here, okay? This one is a little more familiar. It's just a quadratic. And how do we find roots of a quadratic trinomial? Well, we hope to factor, but I can see it's not going to work out. I would say, what numbers multiply to 5 and add to 2? Well, the only factors of 5 are 1 and 5, and there's no way I can get it to add to 2. So how do we find roots if we can't factor? And we would use the quadratic formula. I'm a big fan of using the sum to help you remember it. It's just x equals negative b plus minus minus 4ac all over 2a. But now we're just going to plug in our values, so the coefficients. Here, a is 1, b is 2, and c is 5. So I would resing this: x equals negative 2 plus or minus square root of 2 squared minus 4 times 1 times 5 all over 2 times 1. Plugged it in, and I'm going to simplify. This will give me my 2 roots. It's a quadratic. We know it's 2 roots. So let's simplify here. In the square root, we're going to get 4 minus 20. That's negative 16. So I get negative 2 plus or minus negative 16 over 2. Well, I know the square root of 16 is 4, and the square root of negative 1 is I. So this is going to turn into negative 2 plus or minus 4i over 2.